Air conditioners work by removing heat and humidity from the air to provide a comfortable indoor environment. They use a combination of mechanical and chemical processes to achieve this. Here is a detailed explanation of how an air conditioner functions. Refrigerant. Air conditioners use a refrigerant, a chemical compound with properties that allow it to change between liquid and gaseous states at relatively low temperatures. The most common refrigerants used today are hydrofluorocarbons, HFCs, or hydrochlorofluorocarbons, HCFCs. Components. An air conditioner consists of several key components, including a compressor, condenser, expansion valve, also known as the expansion device or metering device, and an evaporator. These components work together to circulate and alter the state of the refrigerant. The refrigeration cycle. A. Compression. The process begins with the compressor. It receives low pressure, low temperature refrigerant vapor from the evaporator and compresses it, causing the temperature and pressure of the refrigerant to increase significantly. This compression process increases the energy and temperature of the refrigerant, converting it into a high-pressure, high-temperature gas. B. Condensation. The hot, pressurized refrigerant gas then enters the condenser coil, usually located outside the building. The condenser coil is a network of metal tubes with fins that allow efficient heat transfer. As the refrigerant flows through the condenser, it releases heat to the external environment. The heat transfer causes the refrigerant to cool and condense into a high-pressure liquid. C. Expansion. The high-pressure liquid refrigerant passes through the expansion valve, which is a small opening that restricts the flow. As the liquid refrigerant passes through the expansion valve, its pressure drops suddenly. This pressure drop causes the refrigerant to expand and become a low-pressure mixture of liquid and vapor. D. Evaporation. The low-pressure refrigerant mixture then enters the evaporator coil, located inside the building. The evaporator coil also has fins to increase the surface area for heat exchange. As warm air from the room passes over the evaporator coil, the low-pressure refrigerant absorbs the heat from the air. This heat exchange causes the refrigerant to evaporate into a low-pressure gas. Heat transfer and air circulation. A. Cooling mode. In cooling mode, the evaporator fan blows warm indoor air over the cold evaporator coil. The refrigerant absorbs the heat from the air, lowering its temperature. The cooled air is then blown back into the room, while the heated refrigerant gas flows back to the compressor to repeat the cycle. B. Dehumidification. As the warm air passes over the evaporator coil, the low temperature causes moisture in the air to condense on the coil's surface. This moisture forms droplets that collect in a drip pan and are eventually drained out of the system. This dehumidification process helps reduce the humidity level in the room. Thermostat and control. The air conditioner's thermostat monitors the temperature of the room. When the set temperature is reached, the thermostat signals the compressor to stop running. Once the temperature rises above the set point, the thermostat activates the compressor, restarting the cooling cycle. Overall, air conditioners continuously circulate refrigerant through a closed-loop system, using compression, condensation, expansion, and evaporation to remove heat and humidity from indoor air, thereby cooling and dehumidifying the room.